nth term of arithmetic progression. Arithmetic progression can be denoted as AP. Take note of that. Arithmetic progression is also the same thing as linear sequence. So in this case, what is meant by AP? For AP, we have what we call the first term. That's the first thing you need to know. So let the first term of AP be A. If the first term of AP is A, then there exists what we call the common difference, and the common difference is denoted as D. We can denote the common difference as D. The common difference is a difference between two terms. The difference between two terms. Just like constant difference between two terms in an AP or in a linear sequence. Let the common difference be D. If the common difference is D, then when you have the first term, which is T1, we can write A. Then to get the next term, we are going to add D to first term. So second term is going to be, for us to get second term, which is T2. And that's going to be what? T1 plus D. And we are going to have, what is T1? That is A. So this is A plus D. Now for us to get the third term, we are going to add D to the second term. Third term, which is T3. And that's going to be what? T2 plus D. What is T2? A plus D. Then plus D again. T2 is A plus D. Anywhere we see T2, we are going to substitute A plus D. So D plus D will give us 2D. So it means that this will result to A plus 2D. You will observe something. When you have 3 here, you are going to have 2. And when you have 2 here, you will have 1. So take note. Now let's consider the fourth term. The fourth term is going to be what? T4 equals to what? T3 plus D. That is, we add D to the third term to get the fourth term. So what is the third term? That is A plus 2D. Then plus D. So this will give us A plus 3D. Now, we are going to work on the right-hand side here. What we have here. I want to write 3 as a function of 4. How can I manipulate that? I can write this as A plus 4 minus 1D. We know that this 4 minus 1 is the same thing as this 3. Now we can also write 2 as a function of 3. So we can write this as what? A plus 3 minus 1D. This 3 minus 1 is the same thing as 2. And we can also write this as A plus, the coefficient of D here is 1. So I can write 1 as a function of 2. So this is going to be 2 minus 1 D. Then I can also write the last one here, which is A. This A simply means A plus 0D. That's the meaning. Because here 0D is same thing as 0. So A plus 0 will give us A. So I can write 0 as a function of 1. And that is going to be A plus 1 minus 1 D. You will observe something. We are subtracting 1 from the term number. You can say T1, 1 here, that is 1 minus 1. T2, we have 2, then 2 minus 1. T3, we have what? 3 minus 1. T4, we have 4 minus 1. Now we can use what we have here to get the end time of the sequence. Now, for us to get the end time of the sequence, that is, getting the end time of the sequence, what are we going to have? End term of the sequence, which is T4. Then this will give us what? Based on what we have here, T4 will give us Tn rather, not T4, end term, T4, not T4, Tn. So Tn will give us what? Based on what we have here, when you have 4 here, you have 4 minus 1. So if you have n here, we are going to have what? N minus 1. So D. So it means that Tn equals to A plus n minus 1 D. So that is the end time of the sequence, where A represents the first term and D represents the common difference and n is the number of terms. Also, you need to know that the end term is same thing as what we call the last term. That's the last term of AP. It's also the same thing as the end term. Thank you.